But you also can have problems where maybe you want to know what the new pressure is going to be for a gas that you know the delta H of vaporization. So there's always going to be one unknown for this. You just have to kind of read through the problem to figure out what you're going to be solving for. So here is the problem that we're going to work on. And because we have a little bit of time today, I'm going to let you guys work a little bit. I'm going to put the equation up here for you, but I want you to try to work through this a little bit on your own. Okay. So this is problem 3 from that skills sheet. Okay. This says diethyl ether has a delta H of vaporization of 29.1 and a vapor pressure of 0.703 at 25 degrees C. What is its vapor pressure at 95? So this is one that we're not solving for delta H of vaporization. So here I'm going to write down the equation for you, and I'm going to give you guys a few minutes to try to work on your own. And this, of course, is an equation that will be provided for you. Any constants will also be provided for you. So I'm going to write down what that constant is for you. And this is an R value that has different units in it, because we're not talking about liter atmosphere per mole Kelvin. We're interested in energy. So it's still the same value, but with different units. So R is still the same value, but now we've got units of joules per mole Kelvin. Okay, so you guys work for a minute. I'm going to be quiet up here, but I am going to start writing the solution. So don't peek if you want to try to work through this on your own, and then we'll go through it together. Give me a thumbs up if you got 6.57 atmospheres. I know some of you are still working. Normally, this is where I just kind of circulate and sit down next to you and help you if you're stuck, but I can't really do that now, but you can feel free if you are stuck. I want you to feel comfortable asking sort of a question.
I do have a question.
Yeah. And tell me, just you're in my Zoomer group. I love that you're chiming in here. Who is this?
This is Olivia.
Yes.
I was just wondering why you made the vapor pressure negative.
So that in the equation, it's negative delta H of vaporization. So they give it to you as a positive value. So when I put that in there, this negative comes from that negative. Does that make sense?
Yeah, it does. Thank you. I totally missed that.
I'm actually a bit confused about something, but I probably going to sound like an idiot when I ask this. I noticed you took the natural log of P2 over 0.703 there, but you didn't use the P2, the P in the second pressure value that we had calculated previously for that. Or did you? I don't know. I'm just, because that doesn't seem to match.
What I was doing here is in my key here, I just kind of went right from this step down to here. But I wanted to
okay. That's my bad. You skipped over something. That's why.
So for people who maybe didn't know how to solve that algebra, I said, oh, I'm going to go. That's why I sat here with my calculator for a minute.
Yeah, no, that's my bad. That is my bad.
All right, so show me where you guys are at. And I'm going to kind of I'm going to look at the chat or the participants window here for my Zoomers group. Oops, I don't want to do that. There we go. Because what I want to see is if you got this answer in my Zoomers group, can you give me a thumbs up or a green check mark or something? Just give me something kind of that you can let me know if you're good, if you're not good. And then how about my answer questions? How many of you here are good? Few people? Question. Yes, so some of these things might just be calculator things. It's dependent on what calculator you might have. So we're actually not going to be using the natural log here because we're not, we have to actually get rid of the natural log, which we're using the inverse of natural log, which is E. Okay, so if you want to figure out how to use the E, usually on your calculator, there's an inverse button above where E is. Does that help or does that? Yeah. And one of the things I'm realizing, I think lately, is I don't think the green check marks stick around. Like right now, I don't know what it is with Zoom. Like they'll be there for a minute, but they don't stick around. So let me take a second and I'm going to go through this and then we'll see if there's other questions that people might have. Okay. So part of what is challenging with a lot of the problems you're going to see is right now, I told you what equation to use and you just needed to execute it. When you're on a quiz or on an exam, you're not going to have those prompts. You're going to have a big list of equations that you could pick from, but you're going to kind of need to know, well, what do I need to use for this equation? So again, if we look at the pieces of information that are given, and this is one of these strategies, I always like to take the information that are present in words and sentences and just kind of put them in a table, because that sometimes can help figure out, what am I supposed to do with this? So again, we've got an R value, 2 pressures, 2 temperatures, or they're asking for one of the pressures. So once I look at that, those pieces of information, and then the fact that they gave me delta H of vaporization, I know what equation I need to use, and I'm going to be solving for my second pressure. Okay, so give me a thumbs up if everybody's sort of with me on that. So again, sometimes it's not the science that's necessarily the stumbling block here. It might be doing the math to get the answer. So a big thing here is we have to make sure we put things in the right spots. Because if you don't have things in the right spots, just like with our PV equals nRT stuff, it's easy to kind of get the wrong answer. So a couple of other things that are really important here that I want to highlight. More often than not, you are going to need to convert temperature to Kelvin. Okay, we see that we've got Kelvin here. And even though this is taking the difference of things, because it's 1 over, we do need to convert it to Kelvin before we take that difference. Okay, so that's an important thing that could be an easy place to make a mistake. So make sure that you convert to Kelvin. Okay. Second part that you have to make sure you don't miss is the fact that we need to do a unit conversion because these units aren't the same. The units for our R constant are not the same as what we're given for our delta H of vaporization. Okay. So once we do that, then we need to put all of these pieces in. So give me a thumbs up if you're okay to this point. Okay. All right, and I want this place that like our class time is meant to be the time where you guys are like, I don't understand that. Can you go over that again? And so forth. You know, the kind of the concepts and things like that. We're going to flip kind of outside the class because I think those are easier to think about and learn than it is kind of doing the math. Marcus, question?
What do you take the E of like when you're putting in your calculator?
Okay, so let's kind of work through the math now. So then we've got this equation or this hot mess that we're going to be solving for P2. Okay, so to kind of go through this step here, what I do with this piece is I'm keeping this part the same initially. So that's what's over here. And then I have to figure out what all of this is. All of this is equal to positive 2.23417. Okay, so make sure that you're able to figure out that number on your calculator. You might actually need to break this up into even smaller steps. If your calculator isn't giving you the right answer, take 1 over this and then 1 over this, write those numbers down and then subtract them. And then multiply by this and divide by this, making sure to take into account this. Okay, so this is kind of a key number to make sure you can get to. All that really is from is kind of all of those numbers mathematically manipulating them. Everybody kind of good with that? All right, so now to this next part. I've got the ln of a variable, something I want to solve over this is equal to that. To get rid of the ln, I can take I can take both sides, e to the both sides. Does that make sense? So when I take e to this, I get that piece. That's how that comes down there. So e to the ln of something just gives you something. Everybody with me? And then e to the number is just going to give you a number. And now this algebra should be pretty simple. This is just multiplying these two guys together to solve for P2. I feel like I'm seeing a lot of furrowed brows. Questions? Zach, I just can't tell if it's small or if it's a furrowed brow. What doesn't make sense?
Go over the steps again.
So does it make sense how you do this math to get that number?
Yeah.
Okay. And then that's equal to the ln of P2 over 0.703. Okay. I can't solve for P2 when it has that ln in front of it, because that ln applies to both P2 and the 0.703. It applies to their ratio. So I need to make the ln go away. The easiest way to make the ln go away is just to take e to the both sides. When you take e to the both sides, so e to the ln of something equals whatever that something is. That's how I can just get this on the left side. When I take e to that number, I get 9.38762 or something thereabout, depending on how you may have rounded or kept significant figures early on. Does that help? You're not nodding. What part are you confused about?
Okay, so strike the 1 over 360 and the
Yep.
70.
So 1 over 368 minus 1 over 298 is going to be some really small number.
So you do this if you want to divide by 368.
Right. Like,
That's what
Does that help?
Yeah.
Any other? And again, I don't want the math to be what gets in the way of you getting a chemistry question wrong. So show me where you're at. You're like, I'm okay with this. I'm like, not okay. Like, not okay at all. So where are you stuck?
So is it gonna be kilojoules or joules?
Our answer?
Like, so when we convert, like, the negative 29.1 divided by whatever, is it?
That's what I have circled in red there is going to be converting my 29.1 essentially to 29,100, which converts that numerator piece to joules. Right? Because these can't cancel right now. Those won't cancel. So I either need to convert my denominator to kilojoules or my numerator to joules. Doing this essentially converts my numerator to joules. But then those units all go away because we're going to have units of atmosphere in our answer. Does that help?
I just like, I get all these really small numbers and I would say that's.
So part of this too is making sure, are you using your calculator or your cell phone as a calculator?
I'm not using an actual calculator on the website.
With that,
I'm using like graphic website.
do you have like a calculator?
I don't have batteries.
Okay, so maybe let's work offline, get some batteries in your calculator, like schedule a meeting with me and we'll make sure that we get the right stuff on your calculator. Because it's hard to tell where something's going wrong on a calculator question.
Instead of like writing that at the end, would it be the same if I just like turned the 8.314, whatever that is, and just like move the decimal to make it kilojoules?
Yes, you can
Okay,
absolutely
okay.
do that. I tend to make numbers bigger than make them smaller. That's just my mindset is I'd rather see 29,100 than 0.000831. But both of them will give you the same answer. Okay. All right, so I saw some thumbs up, some thumb sideways. What I encourage you, if it's just the math that's getting in the way, let's make sure to work offline if you need to make sure that we're kind of getting things together with calculator and all of that. Okay. All right. So how about we try another one that's like the first problem that we did. Okay. I'm going to go ahead and just copy real quick so you guys have it. This equation and put it here. And then I'll put the answer up here so you guys can know what the answer is supposed to be as you're working through. I did put the answer up on top. And if you don't have time to finish working through it in class, you're not required to, but I encourage you to try to work through it to make sure that you can get to the answer. I'm going to start kind of writing a solution here. I should be able to get it all written out by the time class is done. So even if you're still working, you'll be able to kind of go and check out the video and just fast forward to the very end and you'll be able to see the solution. So feel free to, as you're sort of wrapping up here, if you want, you can take a picture of this if you don't want to have to go back and revisit. This problem is just like the one we did. We're even solving for the same thing. We're solving for P2. So pretty straightforward. Again, if you don't get a chance to completely finish it, that's okay. But I encourage you to try to finish it before you submit your homework, just so that you kind of have a complete problem that you've gone through. Okay, but another opportunity to kind of practice doing these manipulations in your calculator. So certainly something, if you're struggling trying to figure out how to put those things in your calculator, that's, come see me about that. You know, set up a message, either a team session or come to office hours and we can, it's usually a pretty simple fix to make sure that you're good with your calculator. Okay, have a good weekend, guys. And then I will see you guys Wednesday.
Uh,